And on that note, welcome everybody to tonight's meeting. We have Clive, who's going to give us a talk, followed by Horst, who will be walking us through the night sky in July. Though the hours available may be just a fraction longer than this month, and probably still not very much. For any visitors we have on YouTube, you can stay in touch with the Society. You can look at our website, our Facebook page, Twitter, or you can catch up on any of the talks we've had in the past during lockdown on our own YouTube channel. And I do apologise for my voice. It is not getting any better. I'll have to persevere. And just coming up before we start, to remind everybody, on this Friday, we've got Dr. Rosa Santamartino on the BioRock experiment. Wednesday, on the 8th of July, is a members-only meeting. That's the imaging group, and Ian is going to give us a scope talk. On Friday the 10th, Andy Lawrence is giving us a talk on things that are banging the night. And Mark has put his hands up again to do Astro Imaging Part 5, which we'll be talking about imaging for science projects. Professor David Waltham is joining us on the 17th, Is Earth Special? And I think that's going to be quite an interesting talk. Like many of the others we've had. They've been a singularly exceptional quality lately. Thank you everybody who's played their part. And on the 22nd of July, I had the final confirmation that Dr. Noor Rouafi will be joining us from Maryland to talk about the Parker Solar Probe mission. So that's what we've got to look forward to. But tonight, I'm going to hand you over to Carl.
Or to Clive even.
Sorry, to Clive. Voice is just disappearing. Apologies.
Okay, Clive, you want to share now?
Okay. Right, where are we? Share screen. Right, well, good evening, and hello, good evening and welcome, as somebody once used to say. What I'm going to be talking about this evening is an early, well, reasonably early image of the pictorial representation of the Milky Way, which was, well, it was billed as the Lundmark Panorama, and here in the title page I've called it the Lund Panorama, and both names are equally appropriate for reasons that will become apparent. Well, the image that's showing there is what I'll be talking about. As usual, well, as the previous time, I'm broadcasting from Stone in Staffordshire in lockdown, a fact which I will return to as we go along, well, towards the end. Anyway, the Lund Panorama, which we can see there, is a plot in galactic coordinates of the Milky Way, attempting to make a realistic depiction of the entire Milky Way. It reproduces the entire sky, but the most prominent feature is the disk of the galaxy. It's drawn in galactic coordinates, though you can't quite see that because it's dark. But if I fiddled with the color balance of the image and got to the you can there see the galactic grid and the outline, which emphasizes it's not actually a photograph, it is actually a map. It was really the first attempt to make a realistic depiction of the galaxy. It was produced in the Lund Observatory in Sweden, completed in 1955, which I probably shouldn't tell you is the same year that I was born. And it became a very famous image. It was reproduced many times, cropped up many times, in books and magazine articles in the late 1950s and 1960s as a slightly mysterious image of the Milky Way. I didn't really think any more about it, having seen it at the time, until more recently, when for some reason I came across it again, possibly in NASA's APOD, Astronomy Picture of the Day, and was prompted to look a bit into where it came from. And where it came from is the observatory you can see there, bottom right, the Lund Observatory. Or at least that's the historic photogenic bits of it, with the drum domes, similar to the drum domes at ROE, of course. Exactly why the ROE ended up with drum domes is an interesting story, but not relevant to the present talk. The original panorama is 1 meter by 2 meters. There are a total of 7,000 individual stars there painted on, and what was believed to be and attempted to be a realistic depiction of the nebulosity and the dark clouds along the galactic plane. And I've spelt plane incorrectly, I suddenly notice. The wrong plane. The image was a brainchild of Knut Lundmark, hence what I was saying about either name being appropriate. It took 2 years to make, and it was drawn by those two people that I've mentioned there, Martin and Tatjana Kaskula, a husband and wife team. Again, we'll come back to them, and that's showing the grid. Knut Lundmark was a fairly well-known Swedish astronomer. Attended Uppsala University and was awarded a doctorate from them. And for many years, he was the director of the Lund Observatory. Hence, the idea he eventually came up with was made there. He worked mostly on the galaxy and the external galaxies, the early work on external galaxies, contributing to the debate in the 1920s and 1930s over whether the galaxies were all nebulae inside our galaxy, or whether they were external galaxies like our own separate island universes, all of which culminated in the famous Curtis-Shapley debate, which is taken to settle the matter. But might say Lundmark had worked on the same problem and contributed to some of the work earlier in his career. He also studied the solar motion, the motion of the sun, which, as we now know, though they didn't then, it rotates around the center of the galaxy. And he came up with his own scheme for the classification of galaxies, similar to, well, the same sort of thing that Hubble came up with, but different. And other things he was interested in were the history of astronomy, which is always a good thing, in my opinion, and in the popularization of astronomy, which is the same sort of thing we're doing here this evening, of course, in many ways. We'll just have a quick digression. I don't intend to give a comprehensive history of the study of the shape and form of the Milky Way, which will just highlight a few points. Milky Way, of course, in English is just a translation of the Latin Via Lactea, which is, well, it's been known at least since antiquity, if not since prehistory. But modern understanding starts with William Herschel and his star counts that he carried out in the 1780s. And Herschel, of course, also drew up the first, actually not the first, Messier drew up the first, but the most extensive, easily the most extensive for the time, catalogue of nebulae. So their study also can be said to, in a systematic way, can be said to have started with Herschel. And then just in the bottom there, we can see Herschel's famous diagram of the shape of the Milky Way from his paper in Filtrans. So that work carried on throughout the 19th century. But the other significant development I would like to draw your attention to was the introduction of dryplate photography to astronomy following its discovery in 1871. And the great advantage of this was that it allowed long exposures for the first time. Previous photographic techniques, the actual mixing of the chemicals and followed by the developing had to be done in short order of a quarter of an hour or so, which precluded long exposures. But with dry plate photography, which is just the sort of photography we were all familiar with 30 years ago, but with a supporting medium being a glass plate rather than film, the exposures can be as long as you like. And soon astronomers were taking exposures of half an hour, 2 or 3 hours, which promptly revealed, an illimitable number of faint stars, of course, but also the various nebulae that were known had faint outer regions extending far beyond what could be seen by direct observation. And similarly, in some cases, there were what we now know to be dark clouds superimposed on in front of the nebulous regions. Also, I'll briefly mention E. Barnard, a famous American astronomer who he was a gifted observational astronomer anyway, having fought his way up from a fairly hard scrabble upbringing. He became really the doyen of astronomical photographers, initially working at the Lick Observatory, where he fell out with the director apparently, and was later a professor of astronomy at Chicago. And amongst his many activities, and particularly his pursuit of astronomical photography, he took an extensive series of photographs of the Milky Way. And it was he who realized that the dark regions of the Milky Way were in fact dark clouds in front of nebulosity, rather than regions devoid of stars. And the previous idea being you are looking through a region that didn't have any stars and looking out into infinity. And a rather splendid atlas was published from Barnard's photographs a few years after his death, and you can just see it listed at the bottom there. And then just for the next few slides, we're going to have a look at a few of Barnard's photographs, and you can see the star fields, the bright nebulosity, the dark clouds, and again a similar thing. Some of these reproductions probably don't do justice entirely to the photographs, but nonetheless they are really quite impressive, some of them. And that there is a plot in galactic coordinates of the regions that appeared in his atlas, and exactly as you would expect, the photographs all cluster along the plane of the galaxy. The photographs that Barnard was taking and others were taking, wasn't the only way to address this problem. Some work was done in the early years of the 20th century, in the 10s and the 20s and 30s, to draw isophotes, which is what we can see here, an isophote map, basically of attempting to map the brightness, again plotted in galactic coordinates, as you get the increasing brightness as you get closer to the center of the galaxy. So an isophote is just simply the analog of a contour, a region of constant light level, in the same way that an isobar is a region of constant barometric pressure. So again, you can see a sort of outline drawing there that someone has attempted to do. I'm not sure whether this particular one was done by star counts or by attempting to take low resolution photographs and plot the nebulosity. And similarly, some of these representations have started appearing in star atlases. And what we have on the picture there is an image of the polar regions in the 1959 edition of Norton's. Norton's was first published in 1910, and the early editions didn't show the Milky Way at all. And indeed, they also showed the early constellation boundaries just as hand-drawn lines meandering between the rough regions of the constellations. But from the fifth edition in 1933, there was an outline of the Milky Way was shown on the maps. Well, it probably would be the same one that is shown there. It probably hadn't been updated by 59, and also the IAU constellation boundaries we're now familiar with, which were quite new in 33. I think it was 1930 that the IAU came up with the boundary definitions. It was certainly around then. I used to know this. I'm obviously losing my memory in my old age. So much for the background and the potted history of attempts to depict the galaxy. Turning now to the panorama itself, Lundmark managed to get financial support from various institutions, the Royal Physiographic Society of Lund and the Hertz Foundation, whatever that may be. And the image they produce, well, it certainly looks like a photograph, and from the sort of reproductions you see in books, you can't tell it isn't a photograph, but it is actually a painting, a work of art, drawn, as I said earlier, by those two people, Martin and Tatjana Kaskula. Depending which description of the work you read, they're either described as engineers or as artists. But the division of labor was that Martin Kaskula calculated the star positions, so taking the RAs and DACs and doing the necessary spherical coordinate transformations, first to galactic coordinates and then to project the galactic coordinates onto the 8-off projection that the image is drawn in. And he did that for all 7,000 stars, which of course had to be quite straightforward and easy to do. Well, for some definition of easy, easy to do these days with a computer. But doing it 7,000 times is a major undertaking by hand. And Tatjana Kaskula basically painted the nebulous parts. This work took them 2 years to complete, as I say, finishing in 1955. And like a conventional star catalogue or star atlas, the size of the star images indicates the brightness of the stars, and the appearance of the stars is diffused to mimic the way they appear in photographs. Tatjana, as I said, painted the nebulous Milky Way using a brush in the central regions and an airbrush in the fainter outer parts. In order to get the shape, they basically used a couple of photographic atlases, looking at the shape of the clouds and the dark regions in the photographs. Used those atlases there. And because two photographs, if they have different exposure, the actual brightness of the nebula would appear different, which is an endemic effect unless you systematically correct for it using step wedges and things, which you couldn't really do usefully for a nebula at the time. They corrected for these differences, or tried to, by overlaying on the panorama they were drawing isophotos on tracing paper of isophotos that have been compiled by the Dutch astronomer Anthony Pannekoek. I must admit, this is the first time I've heard of Pannekoek, other than his famous book on the history of astronomy, which is again even after all these years, it was first published in 1960 as a good single volume resource. And just to show I haven't been completely wasting my time, those are the actual references for the the atlases and Pannekoek's isophotos. Just looking at the three atlases there, the third one down, the Atlas of the Northern Milky Way. Looking at the two authors, Mary Calvert apparently was a niece of E. Barnard, who herself became a professional astronomer, and her collaborator there, Frank Elmore Ross, basically became the superintendent at the University of Chicago of Barnard's plates after he died. So that's that. As I say, the panorama was completed in 1955, and what you can see in the image on the right there is it being presented to the local Swedish press, with Martin and Tatjana on the left and Lundmark on the right, which, well, I certainly can't see him because he's obliterated by members of the Astronomical Society of Edinburgh, but he is on the right. The panorama, as I said when we came in, became the standard representation of the Milky Way in the 50s and 60s. There are now, of course, more accurate representations from modern digital sky surveys, which are well, it's straight. Once you've got the survey as a catalogue, it's relatively straightforward to produce an 8-hour projection by computer. Again, for some definition of straightforward. But nonetheless, the panorama remains an impressive and alluring object. There was an article about it in Sky and Telescope, which I would have hoped to have consulted. I've not managed it because we're all in lockdown. So that's rather unfortunate. And similarly, I was initially thinking of showing you a few of the reproductions of the panorama in books from the 50s and 60s, because I think I've got several of them. But sadly, they're all in Edinburgh and I'm in Stone, so they are not there either. So nonetheless, the panorama remains an impressive and alluring artifact, and it's still stored safely at the Lund Observatory. That's a modern digital sky survey. That's actually the Gaia data release number 2. And you can see the difference, though you're not quite looking at the same thing there, but more or less. So the panorama remains an alluring artifact, and that's me. And thank you for your attention.
Thank you, Clive. That was very good. It's always informative to look back, and I was born a little bit before you, so some of these are with what you cut your teeth on when you started looking at books on astronomy.
That's right. You couldn't look at a book on astronomy in the late 50s and 60s without coming across it. It was really very well known.
Yes.
Graham had a couple of comments to add. Are you there, Graham? No. Graham Rose mentioning that the ASE has Norton's notebooks somewhere.
Really? Wow.
Well, we'll have to do some
wow. Well, his,
And also, Graham is saying that they've got a copy. We have a copy of that IAU publication.
I think,
I think you've sold it
yes, to
Mm.
Clive.
to me. Yes,
Right.
I can't show you that either because it's in Edinburgh.
If we have Norton's notebooks, they're probably in Graham's flat because I wouldn't know where else it could be.
Graham has indicated he doesn't have a microphone attached, so other than type, he can't answer the question. But
Yeah,
yes,
John, you were adding a comment. Did you want to expand on that?
All I've done is just copy what it says on the IAU website that Eugene Del Porte
Yeah.
came up with the boundaries in 1930. So it says on the IAU website.
Yeah.
On the other screen, and I'll put my version of the panorama behind me. I hope that's okay. I've moved.
It's out of copyright.
Well, it's
It's
actually
shifted.
different because that's actually a map of dust in the Milky Way with I think the Gaia transient alerts on top of it.
Ah.
But it's wrong by 30 degrees.
Is it?
Well, it's a few years after this panorama was made, the radio astronomers figured out where the galactic center really is, and it's, well,
Oh, right.
it's 30 degrees away from the celestial equator.
Hmm.
Oh, there you go.
Radio astronomers killjoys, eh?
well, Graham said he'll have a look for the notes, so that'd be
Yeah.
interesting.
Yeah,
I
that
did
would
notice, Clive, if I can just say that on your copy of the slide showing Orion, one of the early slides, can we go back to that? It was right near the beginning.
Yeah.
Yes, on the top of the right-hand slide, I assume that's not a Starlink satellite. So,
I think it's a plate flow,
all right,
or possibly a scratch in the emulsion.
all right. Not an early meteorite.
It's certainly not a satellite.
I was being facetious.
Lund's a beautiful university town in the south of Sweden. I've been there a couple of times recently, and had I known about this beforehand, I would have made a point of going to the observatory. I've still got connections there, so I think I might get on the email and get someone to go and take a photograph and send it over to me. But next time I'm in Lund, I'll be certain to go there.
That would be good. That would.
When I saw that picture, at first I thought this is Argelander's observatory in Bonn. And it dawns on me, the domes are cylindrical there as well. So it's not just the RE what does it.
No, well, the story, as I understand it, is that in the 19th century, I was kind of hoping someone would ask me this. It's my party piece. In the 19th century, the drum domes were much more common in continental Europe, whereas the hemispherical domes tended to be preferred in Britain and America and colonial observatories. And if you think about early pictures of the Pulkovo Observatory, it initially had drum domes. And when Lord Lindsay was setting up his observatory, of course, he went on a tour of European observatories to find out the latest techniques. And when he came back, the observatory he set up in Ayrshire did indeed have drum domes, and I assume it's because that's the sort of thing he'd seen on the continent. And when ROE moved to Blackford Hill, the new observatory on Blackford Hill was built with drum domes. The notional reason that Copeland gave was that they were better able to stand the Scottish weather. Though I have a sneaking and entirely unsubstantiated suspicion that it's just they had drum domes because that's what they were used to.
Yeah, well, Graham is saying that they used to have one in Colton Hill that was a drum dome.
Oh, right. That I've never seen a photograph of one, but I wouldn't be surprised.
You could argue actually for amateur observatories, these small sort of fiberglass ones, you'd be better off with a drum because you wouldn't have this sort of head hitting on the sides of the dome. It wouldn't look so good in your garden, would it?
And Graham's added that it used to have a 13-inch reflector in it.
All right.
So these are, we learn lots of things on these sessions.
That's very fascinating. Do you have any more questions or comments then for Clive?
No, I don't think so. I think Ian made a comment about using logarithms, but you know, that's maths. Don't we talk about that?
I would imagine they used a mechanical calculator, a Brunsviga, to do the calculations. I would imagine.
Did you want to say anything about that, Ian?
Not unless he turns his microphone on.
He's trying to do it at the moment, I think.
There we go. The original logarithm books, of course, are stored at ROE, although I don't suspect they used them, but just a curiosity. I didn't know there were calculating machines around at that time.
Well, mechanical calculating machines go back to the 19th century.
Yeah, I know I used them in school, but
Yeah. Well, I tried to use them. I never got very far, to be honest.
I used to use them at work.
Yeah. Gracious.
oh well, something else I've learned.
So thank you very much, Clive. Again, once can we thank Clive? That was interesting as always. And we'll hand over to Horst. By the way, Graham's saying he's still got 2 hand crank calculators.
Right, I'll start sharing.
Okay.
Which always takes 10 seconds for some reason. Oh, I have to think what to share. So start the presentation first. No. Whoops. I can't see Zoom anymore. And I need to share this one. Probably.
Yeah.
Well, I have 3 screens, so who knows where
This one's blank.
presentation appears. Okay, that seems to be the right one.
We have some pictures, some flowers.
So that should flowers. You're behind the times, I think. There should be just the presentation, a picture of Jupiter and Saturn. And
Yes.
You got that?
Yeah.
Is my pointer there as well? I don't know.
Your cursor is yes.
Yeah. Okay. I'm not sure I'm using that a lot, but and something I will do is I'll turn my video off. Can I do that? Where can I do that? Oh yes, there. So I have more bandwidth for the audio and the presentation. Right, so the sky in July. I've dug out my best pictures of Jupiter and Saturn because these 2 will be in opposition this month, which is the best time to observe them because they're visible all night and on the other side than the sun. However, summer is not the best time to look at oppositions because the ecliptic is very low, so these planets actually do not get terribly high above the horizon. But anyway, as usual, I start with the planets at dusk and dawn, where they are. And the first thing is at dusk, there aren't any. So I'll skip straight ahead to dawn. So this is the morning sky when the sun is about 6 degrees below the horizon. The grid here is 10 degrees. This is east in the middle. And the first planet I should mention, which may probably be obstructed by people on Zoom, is there on the right, Mars escaping to the right from the morning sky into the night sky. The real morning planet perhaps is Venus, the brightest thing around anyway, apart from the sun and the moon, of course, and it moves away from the sun and upwards. And it also, if you look at it, it slows down. This is because it is moving away from the Earth as well. Venus has just been more or less between us and the sun in inferior conjunction, and it has now moved into the morning sky, and it's moving away and sideways away from the sun as well at the same time. Mercury in principle does the same thing, only it does these things so much faster. It pops up for about 2 weeks, and it does not get terribly high. Even at best towards the end of July, it's only 5 degrees high, and it comes up here on the 18th, I believe, and it goes back down to and disappears early to mid-August. So these tracks go until early August, and the dots are in 2-day distance separations, so every other day. So that's the planets in twilight. The other 3 planets we can look at night, including Mars, which you can also still see in the morning sky. So here is a star chart with Jupiter in it, Sagittarius, the teapot here at the center, Scorpio to the right, Antares, the brightest star in there. And here on the ecliptic, this is the track of Jupiter over the 7 weeks from now until about mid-August. And I must be careful because Jupiter is retrograde, which is unusual for planets, but they do this around opposition. So it moves from the left to the right. It is in opposition on the 14th. And if you get confused by 2 planets, Jupiter is a brighter one, and Saturn is to the left of it. That's the same chart, but now the text is for Saturn. Saturn is fainter than Jupiter, to the left of Jupiter. It is also retrograde because it also reaches opposition only 7 days later than Jupiter. So it is also moving from left to right here. And then the, by the way, the blue line here is the ecliptic, and the red line is the galactic plane, which would have been horizontal in Clive's Lundmark or Lund Panorama. And the galactic center, according to radio astronomers, is somewhere around here. But the optical astronomers could not determine this, and so they set the 0 point for longitude here, where the galaxy crosses the equator. So the 3rd planet visible at night is Mars, which is quite a distance to the left, as it were, from the other 2, and much further north. So it's also easier to observe for that reason, because it gets higher above the horizon. It's roughly in the region of the square of Pegasus is up here. Here the ecliptic crossing the equator. So this is the vernal equinox as a position on the sky. And Mars, to my astonishment, is also retrograde. So it also moves from left to right. Now the planets do this only, the outer planets, around their opposition. And Mars opposition is only in October, so that's quite a long time, and it surprised me that it is already retrograde, but that seems to be how it is. So the constellation where Mars is actually is Pisces, which I have not drawn in lines. There's an oval of faint stars here that I find easiest to recognize if you want to go and improve your skills on finding constellation. And then there's a long arc going around here, and then it turns back to the north. So that's Pisces, and these stars up here belong to Aries, which is already the next constellation. So Mars is not anywhere near opposition yet, so it is not visible all night. You have to, at the start of July, you have to wait until 1 o'clock BST for it to rise. But by early mid-August, it's over 2 hours earlier, at 11:15. And from then on, of course, you can see it until, well, sunrise in theory. On this slide, I compare the 5 planets, how their sizes would appear in the telescope and kind of what they look like, their crescents or phases. But also I've written down the brightness and the diameters down here. So Mercury coming up as a thin crescent, then moving away from the Earth and becoming a fuller crescent and brighter. So it starts quite faint at +1 and ends at -1.6, but that is by the time when it is down on the horizon again, when it is very difficult to find probably. And it's getting smaller because it's moving away from the Earth. Venus essentially doing the same thing, only a lot slower, and it's of course physically larger, and it is much closer than Mercury when it is nearby. So Venus on this occasion is actually probably slightly larger than, almost as large as Jupiter. Usually Jupiter is clearly the largest of the planets, but Venus can compete with it when it's close to the Earth, but starts as a thin crescent. But as it moves away from the Earth, it gets almost diminishes to half the size, and it gets a bit fainter, but Venus is still the brightest thing around. Mars, usually I say Mars is pretty small, but now it is of reasonable size. It starts with 11 arc seconds, and by mid-August it will be 16 arc seconds. And in opposition, I haven't made the calculation, but I guess it would be 20 arc seconds or a little bit more, which is quite good for a Mars opposition. Mars can be relatively far away in oppositions when it's not so easy to, well, not so great to observe. Jupiter, one of the 2 planets in opposition this month. So at its brightest and at its largest, because it's also the closest to the Earth, not when it's in opposition. Saturn, similar. Also for Saturn at its brightest and at its largest. And I always say the size here reflects only the planetary disk. If you include the ring, it's about the same size as Jupiter. On the ring, there is something to mention, which is that near opposition, the ring is quite a bit brighter than it normally is. This is due to the way that the ring particles scatter the sunlight, or reflect the sunlight, if you like, around opposition. So these particles will just reflect a little bit or quite a bit more light just backwards towards the sun. And when we are in opposition, then the Earth is exactly in that direction. And so the ring will appear brighter. It will, the surface brightness, I think it will actually be brighter than the planet, than the disk. You may have seen similar phenomena as probably the Heiligen Shine or the glory when you look down on a cloud, and there's a strong reflection of sunlight just around your shadow. So that was it for the planets. There is yet another eclipse, another lunar eclipse. There was one a month ago. Then it was the moon was north of the ecliptic and moving through the penumbra there. This time it is south of the ecliptic, and it dips a little bit into the penumbra. So this happens on the morning of the 5th. It starts at 4:07 BST. And even then, the moon is only 1.1 degrees above the horizon, and I'm afraid half an hour later, or 20 minutes later, it has set, and by that time it has only dipped 16% of its, or 1/6 of its diameter into the penumbra. So you need a very good, which horizon do you need? Eastern horizon. No, hang on. No, western horizon. It is setting in the west. So you need a very good western horizon if you want to catch this, and you need good eyesight to decide that the moon is a little bit fainter in the upper left due to the shadow. Okay, with that, I'm moving on to the stars at night, stars and nebulae and what have you, constellations. So I start with a view west at these times up here. So at the middle of July, this would be at 11 o'clock. And you get the same stars an hour later if you go out today, or an hour earlier if you go out 2 weeks later on the 1st of August. And one thing I want to mention, even though it's 11 o'clock at night, the sun is not very deep below the horizon here. So the nights are not nearly dark enough to see all these stars. In the west, we see just about Leo setting and Regulus already on the horizon there at this exact time, followed by Virgo on the ecliptic. And high up we have Ursa Major there, the Big Dipper, and Bootes with the bright star Arcturus. And if you wonder which bright star this is, it's when the arc of the bear's tail, it points to Arcturus. And from there on, you can go further, quite a distance to Spica in Virgo. Now, of the ASE 24 objects, there is one in this field which is the famous double star in Ursa Major. It is this one here, where the tail has its corner, or its so the bright one is Mizar, and Alcor is a little distance away, and it should be separable with the naked eye because it's quite separated. And if you point the telescope at it, then Mizar itself is double again. I've listed here Milot 111, which is essentially the constellation Coma. It's a large open cluster of stars here. And M51 is the Whirlpool galaxy, which must be a red marker, probably about there, just under the end of the tail of the bear. Next, looking south, we've already kind of seen this Scorpio there, as high as it ever gets, with Antares here, and this asterism of 3 stars, quite recognizable even in twilight. The teapot, it looks like it's setting, but it's actually still rising. It's not in the south yet. And the 2 planets, Saturn and Jupiter and Saturn, next to it. Here the red line is the Milky Way again, so the Lund Panorama would have bent that way. Here Aquila, the eagle, the constellation, and I've noted here the small constellation of Corona Borealis, which is small but quite recognizable. Objects M13 is the most famous open cluster in the north. And now I have to look for Hercules, the constellation of Hercules. I haven't drawn. It's these 4 stars essentially, which form the main body of Hercules. And on the right side, if you move up 2/3, that's where M13 lies. There's another globular cluster, M92, up there, not far away, but a bit more difficult to figure out what its position is. And I also mentioned the wild duck cluster M11, which is down here by the foot of the eagle. Is that the foot or the tip of the wing of the eagle around here? Which is quite large and quite nice with binoculars, but also worth looking at with a telescope. And then looking east, actually there's quite a few objects to mention here. On the rise is the square of Pegasus, and attached to it the chain of Andromeda, chain of stars. High up in the east is Cygnus, the tail and the head of Cygnus, and the 2 wings. So Cygnus flying to the right, Up here is a small constellation, but very recognizable, of Lyra with the bright star Vega. In Cygnus, the brightest star is Deneb. And if we include Altair from Aquila over here, then we have the Summer Triangle. Over on the right, the W is Cassiopeia. And the objects I should mention, I think these are all from the ASE 24. Epsilon Lyrae is, if you go left from Vega, there is a fainter star, which with very good eyesight you can see as double. It's, I think, about 200 arc seconds apart. So in theory, it should be separable by the naked eye, but you need very good eyesight. And if you point a reasonably large telescope at it, then you can see that each of them is double again, each pair being 2 arc seconds apart. So you need, well, I did see it with 60mm and 80mm apertures, but those were refractors. If you use a reflector, it's probably a bit more difficult to get the contrast and see them separate. But with an 8-inch Schmidt-Cassegrain, it should be easy enough to split them. I forgot one. I forgot number 1 here, Albireo, or I don't know what the English pronunciation usually is. It's the head of Cygnus, the head of the Swan, this star here. It's a wider double star, but it's very interesting because the 2 stars are very different in color. The brighter one is yellow and the fainter one is blue, and this is very clearly visible when you look at it. Then the other objects from the ASE 24, M31, the Andromeda Galaxy, is over here. So you find it coming from the square of Pegasus, following the chain of Andromeda until there's the branch to the north, and there are 2 more stars to find. And then on the second star, you're virtually there. Having said that, this is not the best time to observe it. If you wait into the autumn, then it stands much higher in the south, and this is much better to observe, unless you're worried about straining your neck. The next one is M27, is a planetary nebula, the Dumbbell Nebula, which is roughly in the area of Albireo as well. One way to find it is from the constellation of Sagitta, which is a chain here, and then go north to an asterism that is an M. But you better get a proper finder chart. And I think on our website there are proper finder charts for these objects. M57 is the famous Ring Nebula, also planetary nebula, which is here halfway between these 2 stars at the foot of Lyra. And then there is M15, another globular cluster, which is in Pegasus. So from the square, you follow this. This is actually the neck of the horse, and this is the head. And then you carry on, and up there where the red marker is, that's M15. I've listed Delphinus as a small constellation here, quite recognizable. And then finally, quickly looking north. Not that we usually look north, because these things are as low in the sky as they get when they stand in the north. But there you are. If you're looking for Noctulucent Clouds, then you will find that Capella here is usually visible, and the brighter stars of Perseus and possibly Cassiopeia. There are, okay, M31 is in the image again. M34 is one of the ASE 24. It's this open cluster here. So along the chain of Andromeda to the end, and further on towards Beta Persei, the second brightest star in Perseus, which is Algol, by the way, a famous variable star. And KNH Persei is a double open cluster halfway between Perseus and Cassiopeia, around here. Nice with binoculars, but also worth looking at with a telescope. I did briefly mention Noctulucent Clouds. I think it seems to be a good year for seeing them, except I usually get not so good weather, or certainly this year I don't get such good weather. And my camera is also suffering from the virus because I can't take it to work for a proper view north. This picture is taken by David from the Borders. It's a panorama he stitched together, showing the Noctulucent Clouds, yeah, near the solstice. So these are clouds we see during twilight when the sun is between 4 and 16 degrees below the horizon, and we look north towards where the sun is behind the horizon, and they appear between late May and early August. It's actually quite a miracle that these clouds form, because they can form only there where it is the coldest place in the atmosphere at the coldest time of year for this. But even so, there is not much air and even less water vapor to form clouds. But little that there is, this time of year is just cold enough to freeze some of that out. And then we also need the meteoric dust to form them. And these things have not been seen before the late 1800s, so they have not been there before the Industrial Revolution. Then finally, there are one or two other things. The solstice, when the sun is highest in the sky, was on the 20th in the evening. If you want to calculate the hour when it was, on the 4th or 5th of July, we are in aphelion, which is the Earth's longest distance from the sun, 152 million kilometers instead of the average 149.6. And you may have noticed this, the nights are very bright and short. Every night there is civil darkness, but there is no nautical darkness around the solstice. And the first time it gets nautically dark again is on the 12th of, on the morning of the 12th, or midnight, sort of midnight, 11th to 12th of July. And getting proper dark astronomically when the sun actually dips to minus 18 degrees, that does not happen until the 9th of August. And well, these times are close to midnight, so it's that darkness then on that night lasts only about 20 minutes. But the nights will get longer in autumn. So with that, I'm moving on to some Flickr images from the imaging group on Flickr. Starting another picture by David Small taken in May on the 24th. So this was just after Venus over here on the right had dropped lower than Mercury. This was 2 days after they were close together. But that meant that the moon has joined the party over here, the crescent moon. And I assure you, Mercury is in the image. It's up there, and if you don't believe it, this section is in original resolution, and there it is.
You can see it.
Sorry, come again?
Can see it.
You can?
Yeah.
Yeah, even in there, in the small one.
Yeah.
Yeah.
Oh, okay. This picture, also late May, is by Fran of the lunar crescent, which I think is a nice balance of the blue background and the white moon. Nigel took this image in mid-June of the Whirlpool Galaxy and its companion galaxy, and of course you can see the tidal disruption of the spiral arms of the main galaxy. Oh, and that's it for me. So there we are.
Thank you very much, Horst. It sounds like Fran's got a new name. Fran of the Lunar Crescent.
That's not what I call her.
Well, Great. Thanks very much, Horst. I think we're all wanting the good weather to return, but won't be unhappy when the nights get a little longer. But we are selfish, I think, in that respect. So unless anybody else has got anything they just want to bring up, I guess that's the formal business done. Anybody got anything they want to raise?
Yeah, I've got one, Andrew.
Yeah.
Yeah, I was speaking a couple of days ago with, do you remember when we set up the meeting with Andy Lawrence up at the observatory with when we were setting up the Charles Piazzi Smythe? The woman that was involved there, she's a regular customer, and so she was pleased to hear we'd enjoyed the video of the expedition.
Right. Yeah.
And they send their best regards for all the Zoom meetings, etc.
Excellent.
I was just going to make a quick comment about the Noctulucent Clouds that have suddenly appeared behind me. Keep on moving, you know. It's raining here, so they're not real. That's the first time I've ever photographed them right up to the zenith. I didn't believe it was physically possible. But the images I've got with the camera pointing vertically show a clear boundary halfway across the sky. I was quite surprised. They weren't particularly bright. The pictures brighter than they actually looked in reality. But I didn't think the sun could illuminate them at 90 degrees, but apparently you can.
It's rare, yeah. It's rare that they reach that far. But I remember last year, around the solstice, I desperately wanted to use the big telescope and take a guided image of the Ring Nebula to test the guider. And I couldn't because there were this wave pattern of Noctulucent Clouds in the zenith.
Right.
Yeah.
First, do you want to comment on Graham's note on the chat? Have you got the chat open?
No, I don't have the chat open.
Okay. He's saying he's got a couple of volumes of Webb's Celestial Objects for Common Telescopes with Norton's handwritten notes. And the website says Horst has the other Norton notebooks.
Notebook. That's somebody else's book where Norton has put in notes.
Yeah.
That's not what I understood. Oh yes, JCMT is a drum. That's right. Yeah.
Yes.
Yes, we have I think we have a Norton that has Norton's notes in it, something like that.
Well,
yes, we do have Norton's drawing tools. Ken Thomas has those at the moment to have a look at them. So yes, there is some connection with Norton from the society. And we have quite a few Norton versions from the years, but some we sold, the newer ones and the doubles.
Well, perhaps at our next physical meeting, we might want to attempt to gather a few just of those particular items together. It'd be quite an interesting exercise to let members just have a look.
Yeah. Yeah. Yeah, that's the ASC24 URL.
Okay.
Yep.
Anything from anybody else?
So I've got one of the later Nortons that's got one of the in-vid path ones, and that's actually got a printing error in it. It's actually a labelling error that apparently been there for several years that no one noticed till I met Ian and told him. So that's a deliberate error that people obviously didn't spot.
Easy done. Okay, I guess then that's the business concluded. I don't know if you want to just pop the future meeting slide back up, Mark, and then just remind anybody who joined later what's coming up. Although Mark is doing an excellent job of putting the week's highlights up for everybody to access the the information. So thanks, Mark. And I'll see you all, or talk to you all on Friday. Good night.
Yeah.
Hey, good night all.
Night, folks.
Right, thanks.
Good
Right.
Good night all.